Next, if I'm graphing f of t equals 1/2 cotangent of x minus 1, let's go ahead and first talk about what the transformations are. So the vertical stretch is 1/2. Okay, my period doesn't change, so that's going to be pi. My phase shift, there is none. And my graph is being shifted down 1 unit. We'll talk about domain and range once we sketch the graph. So first, let's go ahead and label a couple things on our x and y axis. So I'm going to let this be pi over 2. I'm going to label this as pi. And then I'm going to let each of these tick marks be 1. So this is 1, 2, and -1, -2. All right. So for cotangent, let's go ahead and start where the asymptote is at 0. So since there's no shift and there's no period change, my asymptotes are going to stay the same. So my asymptote is at 0, the period is pi, so it goes to pi. Okay, now I need to build my midpoint. So my midpoint is halfway in between, but remember it shifted down 1 unit. So my midpoint is going to be right here. Now remember what the parent function of cotangent looks like that. But this one has a stretch of 1/2. Okay, so that means instead of going over or halfway and up 1, we're going to go halfway and up 1/2. Okay, same thing. Instead of going halfway, then down 1, I'm going to go halfway and down 1/2. I'm going to connect the points. And there my graph is. Oh, wait. There we go. All right, so the range for this function is -infinity to +infinity. And the domain is all real numbers except x cannot equal. My first asymptote's at 0. And it occurs every pi. So k pi, pi k, whichever you prefer. All right, last graph. I am graphing the cosecant of 2 times x minus pi over 2. So first, let's write the equation of the helper function. So I have y equals, the reciprocal of cosecant is sine. So sine of 2x minus pi over 2. So the transformations on this, there's no vertical stretch. The period for my function is 2 pi divided by b, so it's pi, so it's being compressed. My phase shift is going to be to the right, pi over 2. There is no vertical shift, and we'll come back to domain and range once we have graphed it. So labeling my x and y axes, let's go ahead and label, since my period is pi, let's just go ahead and do pi over 2, pi. But again, you don't have to choose these exact labeling as long as you sketch the function correctly. You can label it however you would like. So I have 1, 2, -1, -2. All right, so let me first sketch what the helper function looks like. So it's shifted pi over 2 to the right. It starts at the midline, then it goes up to the maximum. Up to the maximum, down to the midline, to the minimum, and back to the midline. Much better graph. Okay, so there we go. It takes place over pi. Now everywhere the sine curve crosses the midline, that is where the asymptotes are going to occur. your local maximums become your local minimums. And your local minimums become your local maximums. So my range is going to be negative infinity to -1. It includes the -1 union, picks back up at 1, and it goes to infinity. Okay, domain, it's going to be all real numbers except x cannot equal where the asymptotes occur, which is 0 and then plus every pi over 2. So x cannot equal pi over 2, okay. All right, given the amplitude, period, vertical shift of each graph, label the x-axis by 1s, then write the equation of the function. So 1, 2, 3, 1, -1, -2, -3. Okay, so if this is a sine function, I'm going to go ahead and highlight what this function is. So sine functions always start at the midline. It's going to be here. And then I don't see the full thing, but I know it's going to end somewhere right about there. All right, so my midline is at 0. My maximum is at 3. And my minimum is at -3. So that means my amplitude is 3. My period, it looks like the one full cycle takes place over pi. Okay, phase shift is to the right. Pi over 4. Vertical shifts, there is none. So now let's write our equation. So I have y equals, my amplitude is 3, sine, okay, my b value. If my period is pi, so pi equals 2 pi divided by b. I know that my b value needs to be 2. So 2 times x, phase shift of pi over 4 to the right, so that's -pi over 4, and that's it. Okay, if we were assuming this was a cosine function, we'll go ahead and sketch the cosine function in blue. So cosine function, this is starting at the minimum, and here we have one full cycle. Okay. But again, the amplitude doesn't change, the period doesn't change, there is no vertical shift. So my amplitude is going to be 3. My period is pi. There's no phase shift this time. There's no vertical shift. But notice that there is a reflection because it does start at the minimum. So you may want to write that reflection. So my equation is going to be y equals -3 cosine 2 x. All right, next one. First we're going to assume it's a sine function, then a cosine function. So if it's a sine function, I'll highlight this in yellow again. This is a sine function is going to start at the midline. So first we need to determine where the midline is. So if 1 is my maximum, if -3 is my minimum, that's a total distance of 4. So half of 4 is 2, so I know that my midline is going to be right here at -1. So if I'm tracing, I'll trace my sine function in purple. So my sine function, here we go. I'm going to trace one full cycle, and there's one full cycle. So my amplitude is going to be 2. That's the distance between my midline and my maximum, midline and minimum. Okay, my period, let's see, my period is 6 pi. So if I'm finding my b value, that's 6 pi equals 2 pi divided by b. b is going to equal 1/3. Okay, notice there's also a reflection because it decreases first. And there's no phase shift, vertical shift. My midline was shifted down 1. So now for the equations. My equation is y equals negative 2 sine 1/3 x minus 1. Okay, now for my cosine function. So if I was to highlight my cosine function, go ahead and do it in blue. So cosine function, here we go, starts at the minimum. I can't see the full thing, but I don't really need to know the full thing in order to be able to write the equation. So notice that the amplitude's the same, period's the same, but this one has a phase shift of, it looks like, what is that, negative 3 pi over 2. So my amplitude is 3, amplitude's 2, period is 6 pi. Phase shift is to the right, 3 pi over 2. My vertical shift, down 1. So my equation, let's see if it starts at the minimum or the maximum. Starts at the minimum. So that means that there's also a reflection. So I have negative 2 cosine 3 pi over 2 x minus, whoopsies, that's not supposed to say 3 pi over 2. My b value is 1/3, so that's going to be 1/3. There we go. 3 pi over 2, and then down 1, minus 1.